like if you recall initially we were like the limit, continuity, and then differentiability as are related, right? And then what we've been doing so far, we've seen that if you want to find if the function is differentiable at a point, you check if the limit exists at that point, right? As each is approaching zero. One thing about differentiability too is that at a particular point, if that function is continuous at that point, then it's differentiable at that point, right? So then if it's I don't want to be saying a lot of words, but if it's discontinuous at that point, then it's not differentiable at that point. Most of the times we can look at the graph and then see whether now we are here and see whether the the function is continuous or discontinuous, right? But there are some common features of the graph that help you to know whether it is continuous or is discontinuous, right? But some of them are very common. Let's look at those ones. When you look at this particular graphs here, these are examples of the discontinuities, right? So you see, so whenever we are having a sharp change, because when we started at the beginning, we were like differentiability, slope, right? Changing y, so differentiability, slope, changing y, changing x, right? We talked about this and we still talk about it, right? And then the moment we are not having anything that's having a change of this form, the change will be very fast, right? I'm just using that scenario to give us an example. The change will be very fast, so we will notice. So one thing to help us know is that the moment you're having the graph and then you see a very sharp change of this form, at that point where there's a sharp change, the function is not differentiable. It's not continuous there. And you look at this one. These two here are the same functions, right? This one here and this one here, they're actually the same function. So, but what happens is that at this point, the function ends here, and at this point here, it continues at this point. So there's a discontinuity. So, but this particular one is called a jump because it ends here and then boom, it continues from this side, right? So that's what we call discontinuity. These are just the understanding part, but the actual things you have to know how to actually use them, right, and apply them. As I was saying, if the function is differentiable at the point, the limit as h is approaching 0 at that point should exist, right? It should be continuous at that point. But we'll check the continuity later. I think it was at the function side, right? This also, I'm coming. So this one, when there's a sharp change of this form, this is a sharp change, right? This one is a sharp change, right? This one is a jump. And this one, when what do you call it? What's the name? The vertical line, the tangential line to at that point is just curved. These are just graphs. I don't think they give graphs, right? So let's check the continuous point. The continuous at the point says is that when you want to check if the function is continuous at the point, one thing is that it showed is at the function side. If it's on a particular point, we're trying to refer. I don't want to misquote anything. Okay. The function is continuous at a point, right? If the limit as the function is approaching that point is the same as just putting the function, like the value into the function. So let's say you have a limit release of this sort, and the function is, let's say, 2x plus 4, right? And we want to know whether the function is continuous at a point, let's say 2, right? If you want to check, it's the same as just putting the 2 into the function, right? Which will be just 2 into bracket 2 plus 4, right? If this value exists, in this case, what we have in 4 plus 4, which is like 8, which exists, and then you check the limit, right? As the function is approaching 2, and then check is actually the same 8, then we can see the function is continuous at that point. That's what it means. Let's see, it was here. Okay. So a function is said to be continuous at a point if the limit, right, of that particular function is the same as just putting the point that we are approaching in the function. That's all. So you see, when you find the limit of the function, and it's the same as just putting that value that we're approaching, the value that we are trying to check that the function is continuous at within this way, and then they are the same, fine, then it's actually continuous at that point, right? So most of the times, as I was saying, every topic that you do in maths are interrelated. Continuity, continuity, differentiability, and the limit. Everything is related. But at times, because it's the same something, if you don't get, you can just go back and go and check, right? Hmm. Then after all this side, we go to the next side. This side is full of rules. This is the point where if you don't know the rules, there's nothing you can do, right? So that's the so let me just do some short something. Now we are here, right? Here is where you actually have to know what's happening, right? If you don't know what's happening, you'll be able to solve. We have the general differentiation rules, and then we have the ones that they are actually constant. To derive them take a lot of time, so you just have to memorize them, right? All right.